All right, this video deals with section 5.3 and 5.4. 5.3 is just a statement about mass as we use it in physics. So you may have seen it defined in a chemistry class as something like the amount of matter in something. All right, in physics, we use a different definition. We use the mass of an object is a measure of its resistance to change in motion. The more massive an object, the harder it is to change its motion. All right. There's really not a lot more to say about mass. We've already talked about the difference between mass and weight, right? We said that weight is the force of gravity on an object. And we said that that's equal to, if I call W weight, the magnitude of weight is m times g on the surface of the Earth. Right. If we were on another planet or out in space or whatever, or we're talking about the force of gravity between two objects other than the Earth and something, then it's different. We'll talk more about that in a later section. All right, so now that we have a definition for mass, we can talk about Newton's second law. Newton's second law arrives as you try to look at the relationship between force and the motion of an object. So observe the motion of an object under varying forces. So if we apply some force to some object, we observe some acceleration. Imagine this is, something with wheels or something sliding on ice where we have no friction. Now, if we double that force, apply it to that same frictionless mass, and we get 2 times the acceleration, etc. So what we observe here is that the force is proportional to the acceleration. Now you make a similar experiment where you, instead of varying the force, now vary the mass. So apply a fixed force, but vary the mass. So again, if we have that force applied to some mass and we observe some acceleration, now let's double the mass. So we apply the same force F to a mass of 2m, and we observe 1/2 of the acceleration we observed before, etc. And we observe that acceleration is proportional to 1 over the mass. And we can combine those and say that acceleration is proportional to the force and inversely proportional to the mass. And now make an observation here. The Newton, which is the unit for force, is defined as the force required to accelerate a 1 kilogram object at 1 meter per second squared. What that means is the Newton is chosen such that our proportionality constant here is 1. So we can in fact write this as an equality. And the way that, so let me go ahead and write that down. So we get an equality, and the way that you'll usually see this equation written is that the sum of all forces is equal to the mass times the acceleration. Right, in our thought experiment here, we were just using a single force applied to an object, making it accelerate, but it holds for the net force or the sum of all forces that it's true, and it is a vector equation. So we can look at components, and the acceleration is in the direction of the net force. All right, what else do I want to say about Newton's second law? Anything? I think that's enough for this video. We will do more practice problems with this in class, and we're going to practice our free body diagrams. Using a point approximation to determine component forces and build equations of motion. All right.